India is currently engineering one of the most aggressive economic expansions in human history. We are watching a nation build entirely new megacities and industrial hubs at a pace that rivals any superpower on Earth. But keeping a grid of this magnitude online requires an incredible volume of continuous, reliable baseline power. The concrete, steel, and digital infrastructure pushing this growth forward all share an insatiable appetite for raw energy. Here is the structural flaw hiding beneath all that momentum. Despite its massive domestic workforce and manufacturing capacity, India does not actually own the fuel needed to keep its own lights on. To maintain its current output, the country relies heavily on a constant, massive influx of foreign oil and natural gas. Millions of barrels must be shipped in from outside its borders every single day just to maintain the baseline. Even when planners look at alternative baseload options like nuclear power, the vulnerability remains. The uranium required to run those reactors is almost entirely sourced from international suppliers. The widely accepted strategy to fix this is to accelerate away from fossil fuels entirely. Policymakers argue that by aggressively adopting next-generation solar, wind, and battery technology, the country can finally cut its ties to foreign petrostates. On paper, this massive shift toward a green grid looks like the perfect escape route, offering a clear path to true energy independence and absolute national sovereignty. Building that green future requires an entirely new class of hardware. We mean advanced microchips, massive battery storage facilities, and complex electrolyzer stacks, which are specialized systems that use electricity to split water into hydrogen fuel. But producing these components introduces a microscopic level of manufacturing precision, which in turn demands a highly specialized, totally different chemical supply chain, one vastly different than burning coal or gas. This map illustrates the transition paradox. While a solar-powered grid retreats from foreign oil, those panels and batteries remain bound to critical rare earth minerals. Green infrastructure is impossible to construct without elements like iridium, platinum, cobalt, and lithium. Harvesting these elements requires a sprawling, intensive industrial footprint. Look at lithium evaporation ponds. They span massive geographic areas, taking years to extract the chemical compounds required for just a single generation of batteries. India lacks domestic access to these specific deposits. To build its green grid, the country must import almost all of these critical minerals, transferring its reliance to a new set of foreign mining monopolies. By copying the standard global green tech model, the country maintains its supply chain vulnerability. It has simply exchanged its historical reliance on Middle Eastern oil for a new reliance on foreign rare earth metals. India's expansion currently faces a dilemma, caught between the old fossil fuel legacy and a new, restrictive dependency on imported battery metals. Synthetic fuels offer a route around these global bottlenecks, allowing the country to manufacture its energy rather than extracting or importing it. Domestic innovators like biogenic orja are focusing on this specific outcome, developing proprietary chemical processes designed to manufacture high-grade fuels from local materials. This flowchart breaks down the mechanics. Instead of pumping crude oil, biogenic synthetic fuel is created by processing local organic agricultural waste into high-grade energy. Working with existing engines, this sidesteps massive battery banks, removing the need to import cobalt or iridium. By treating fuel as a manufactured product rather than an extracted resource, this technology turns a critical geopolitical weakness into a self-contained domestic energy loop. Zooming out from the specific chemistry of synthetic fuels reveals how these engineering decisions dictate India's positioning on the global stage. Energy security is the core currency of modern political leverage, determining exactly how much weight a nation carries in international negotiations. As long as outside nations control the physical choke points of raw materials, India's political mileage will always have a hard, unforgiving ceiling. A country cannot freely execute foreign policy if its baseline power is controlled by an external supplier. Scaling homegrown innovations, like the tech developed by biogenic orja, cuts those external chains, neutralizing the leverage those foreign monopolies currently hold. Establishing total energy sovereignty acts as a physical and economic shield, insulating the nation against trade wars, sudden sanctions, or global supply chain collapses. Global leadership in the 21st century belongs to nations capable of engineering their way out of geographic and natural resource limitations. The future belongs to the engineers of absolute independence.